Hi there, my name is Raja Guha Thakurta, and I'm a professor of astronomy and astrophysics at the University of California, Santa Cruz. I got my PhD from Princeton University on the East Coast many years ago. Before that, I was a college student and high school student, a physics major in college, in the city of Calcutta in India, my college and high school studies. Um, my research, to put it very succinctly, my research is on galaxies. I study dark matter on galaxy scales, large galaxies, small galaxies, dwarf galaxies, and giant galaxies. I study collections of galaxies called clusters of galaxies, but I'm very interested in the dark matter, the gravitational glue that holds galaxies together. I'm very interested in how galaxies serve as sites for the chemistry of the universe to evolve. Chemical evolution happens through the birth and death of stars, and all of that is hosted by galaxies. So I study galaxies for their dynamics, for their dark matter content, for their assembly history, for their chemical evolution history, all of these aspects. I got started on research only when I came to graduate school in 1985, and my very first project was not on galaxies, but my second one was, and ever since then, ever since 1986, I've been involved in research on galaxies. Many different aspects of research, as I'll say a little bit later. But so I've been doing research for 33 years, and most of that time I've been researching different aspects of galaxies. Um, I am currently conducting the research, of course, right here at UC Santa Cruz, but my research instruments, I'm an observational astronomer, my research instruments are located around the globe. I go use the Keck telescopes on Mauna Kea on the big island of Hawaii. I go there a few times a year. Um, Talking about around the globe, quite literally, the Hubble Space Telescope is in orbit around the globe, and I use a lot of data from the Hubble Space Telescope, as do many of my colleagues. Most of the research I do involves those two telescopes, the Keck telescopes in Hawaii and the Hubble Space Telescope in orbit around the Earth. But I also use telescopes in Chile, telescopes in Arizona, telescopes in other parts of California. So my research involves collecting data from telescopes. My research also involves a lot of working with people, with faculty colleagues like people in faculty positions like myself around the world, with research staff, with post-PhD researchers, postdocs, with graduate students, master's and PhD students, with undergraduate students, and even with high school students. So I do research with people of a wide range of ages and educational experience. And to do my research, I make measurements of individual stars or the collective light of stars in galaxies. I take spectra, I take images. Spectrum is worth a lot of pictures because the spectrum contains a lot of physics. So we use spectrum to measure the velocity of a star through Doppler shifts. We use a spectrum to study the chemical composition of the outer layers of a star. So a spectrum really helps you get into the physics behind the object that's shining. Now, so my techniques are really observational, and what I do is I'm very interested in the question of how the lives and times of galaxies and how that relates to you and me, life on Earth and chemical evolution on Earth. Because one of the things I see is I see that there's a very strong connection among these things. If our galaxy didn't contain the amount of dark matter it contains, then it would not be as good at retaining the material from exploded stars. Stellar explosions are really important for chemical evolution because they create the explosion. During the explosion, many elements in the periodic table are created, but they also serve as a dispersal mechanism. The stuff that was created inside the star gets dispersed through space and gets incorporated into the next generation of stars. These explosions are so energetic that if our galaxy didn't contain the dark matter it contains, the material from the explosion would escape our galaxy and wouldn't be incorporated into subsequent generations of stars. So I'm very interested in that connection of how chemical evolution on Earth has, of course, had its bearing on the development of life on Earth, but how that's related to galaxies, their dark matter content, how galaxies collide and cannibalize each other. These are all topics of great interest to me. If you are interested in doing research in any one of these topics, please come talk to me in person. I'm more than happy to discuss my research with you, as are most faculty. You're welcome to come sit in on some of my lectures, in my introductory lectures or in more focused talks. And most importantly, I've done research with many undergraduates on the UCSC campus. Many of them have done senior thesis projects with me. I would encourage you to talk to them to get from the boots on the ground experience of what it's like to be a student working in my research group. Thank you. I look forward to chatting with you. So at one